Hey folks, this next video is about reference frames. Reference frame is really just the perspective that the observer in a physical event has, where they are and whether they're moving or not. In this first video, we're going to talk about how the reference frame will determine the direction of vectors if you put the observer in different locations. In the second video, we'll move the observer and talk about how that can change the magnitude of some vectors. We're using a free fall problem that I've started to set up here, and we're going to solve it from two perspectives. One, we're going to put the observer on the ground, and the other, we're going to put the observer on the top of the building. So if you look at the picture, the observer is on the ground here, and there's a person up here who's going to drop the ball. So you've done stuff with motion detectors recently. Imagine that the observer is just a motion detector that's on the floor looking up at the ball. Because the motion detector is pointed up is the positive direction, and so that's going to influence some things. On this picture, I only drew one person because I'm imagining that the person dropping the ball is also the observer. And that's like putting a motion detector at the top of the building, facing down, and the ball's going to move away. This makes down the positive direction, and so that's the only difference really between these two observers. I set up some initial conditions. Initial velocity 0 for both, because that's at rest, no direction there. Time is a scalar, so that's the same. And the real difference here is that the acceleration is negative 9.8 meters per second for the observer on the ground, and positive 9.8 meters per second for the person on the building. Again, acceleration is downward, and so the direction we choose as positive will tell us whether the acceleration is positive or negative. We now set up a calculation with this first kinematics equation, and I really only need to solve it once. The final velocity is going to be 0 plus, and then for this observer on the ground, negative 9.8 times 3.5 seconds. And so the velocity with which the ball hits the ground is negative 34.3 meters per second. If I do the same thing for this one, it's v equals 0 plus a positive 9.8 times 3.5. It's the same numbers, except both positive this time. I get the same answer. And these are velocities. My question asked the speed, and so the final answer, no matter which direction is positive, is 34.3 meters per second. And this is one of the keys of reference frames, is that by changing your reference frame, you're not changing how physics works. And so all of your answers should be consistent with one another. They might just have opposite signs because you chose a different direction than you could have. This is not really important for us yet, but when we get to the AP exam, when you are answering questions like this, you will be asked for speed instead of velocity, because one student might choose up as positive and another might choose down as positive, and you would have different velocities, but you would both have the same speed because the speed is just the magnitude of the vector. So if you want to play around with reference frames, it can be a little rewarding to decide that down is positive or left is positive in some situations. As we go through more of the course and learn more vectors, we will sometimes have to choose a specific reference frame just to make our lives easier. And that's it.